Namaste everyone and a warm welcome to our channel. I am so excited to guide you through a super important topic in Java today, memory management and garbage collection. You see, when you write Java programs, your code needs space in your computer's memory to run and store data. Java handles a lot of this automatically, which is one of its biggest strengths. Today, we will demystify how Java manages this memory, especially focusing on something called garbage collection, which is like a friendly cleaner for your program's memory. By the end of this tutorial, you will understand where your data lives, how objects are created and removed, and why you do not have to worry too much about cleaning up memory yourself. This knowledge is fundamental for writing efficient and robust Java applications. So, grab your virtual notebooks and let us begin this exciting journey into Java's memory world. Alright, let us dive into the two main areas where Java stores data, the stack and the heap. Imagine your computer's memory as a big cupboard. The stack is like a set of neatly organized drawers used for quick access. It stores things like method calls, for example, when one function calls another, and also local variables and primitive data types, like integers or booleans. These items have a very specific, short lifespan. When a method finishes, its information is simply popped off the stack. On the other hand, the heap is like a much larger, more flexible storage area. This is where all your objects live, such as instances of classes like string or student. Objects on the heap have a longer, more dynamic lifespan. Understanding this distinction is crucial because it helps you visualize where your program's data resides. Look at this simple code example. Here, the primitive int(x) goes onto the stack, but the myObject obj is created on the heap. Now, how do objects on the heap actually live and eventually die? This brings us to the concept of object reachability. An object is considered reachable if your program can still access it through a reference. Think of a reference as a pointer or a handle to an object. As long as at least one active reference points to an object, that object is alive and well on the heap. However, when an object is no longer referenced by any part of your running program, it becomes unreachable. It is like having a book on a shelf, but no one has the key to the shelf anymore. The book is still there, but no one can get to it. Once an object is unreachable, it is a candidate for what we call garbage collection. This is a very important concept for understanding how Java automatically manages memory. In our example, when we set myObject is equal to null, the original object it pointed to becomes unreachable if no other reference points to it. This is where the magic of Java's garbage collector comes in. The garbage collector, often abbreviated as GC, is an automatic background process in the Java virtual machine that identifies and removes unreachable objects from the heap memory. Its primary job is to free up memory that is no longer being used by your program, preventing what we call memory leaks and ensuring your application runs smoothly. The best part: you, as the programmer, do not have to manually delete objects. Unlike languages where you might use free or delete, Java takes care of this for you. The garbage collector runs periodically, and its exact timing is determined by the Java virtual machine. While you can hint to the system that you would like the garbage collector to run using system.gc, please remember that this is just a suggestion and the Java virtual machine might choose to ignore it. The garbage collector is truly one of Java's most powerful features for robust programming. Even with automatic garbage collection, there are still a few common mistakes beginners make that can impact memory usage. One common mistake is holding on to strong references to objects that are no longer needed. For example, if you add many objects to a static array list and never remove them, those objects will remain in memory even if they are logically no longer required by your application. This can lead to a memory leak because the garbage collector cannot clean them up. A best practice to avoid this is to set object references to null when you are absolutely sure they are no longer needed. While the garbage collector will eventually find unreferenced objects, explicitly nulling out references can sometimes help it identify candidates sooner, particularly in long-running applications. Another important best practice is to always close resources like file streams or database connections using private resources to ensure they are properly released, preventing resource leaks that can indirectly affect memory. Fantastic work today, everyone! We have covered a lot of ground in our journey through Java memory management and garbage collection. Let us quickly recap the key takeaways. We learned about the two main memory areas, the stack for method calls and primitive types, and the heap for all objects. We understood that objects are removed from the heap when they become unreachable, meaning no active references point to them. And finally, we discovered the incredible role of the Java garbage collector, which automatically cleans up these unreachable objects, making your life as a programmer much easier. Remember, while Java handles most memory management, understanding these concepts empowers you to write more efficient and robust code. Keep practicing, keep coding, and keep exploring. If you found this tutorial helpful, please give it a big thumbs up, share it with your friends, and do not forget to subscribe to our channel for more exciting Java tutorials. Happy coding, and I will see you in the next video.